In this video, we're going to look at an application of logs involving the Richter scale, which is defined, the magnitude on the Richter scale is defined to be the log of I sub c over I sub n, the ratio, which is the ratio of the intensity of the quake measured 100 kilometers from the epicenter to the intensity of the movement of the Earth on a standard day, which is a given. So what the Richter scale does is it measures the relative intensity, which usually comes out to be a very large number, and then uses logarithms to make it smaller and fit on a scale. So let's say we have an earthquake that is 20 times, let's say an earthquake is 20 times more intense than another. So we want to know how much larger its magnitude is on the Richter scale. So let's set up an equation for both of these. So r sub 1, let's make that the more intense one, equals log of, what we'll do is we'll say, okay, the intensity of the smaller one will be I, so the intensity of the larger one will be 20I over I sub n. So there's our larger one. Our smaller one will be r sub 2, which equals log of, well, we said its intensity is just I over I sub n. So what we're going to do, and this is common with these kind of problems, we're going to subtract the two equations, because what we wanted was the difference in their magnitudes on the Richter scale. So let's see what happens when we subtract them. We get log of 20I over I sub n minus log of I over I sub n. Now most of our work is going to come in this next step right here, which is to use properties of logs, because we have subtraction. That means we can rewrite it as a single log with division. Specifically, 20I over I sub n over I over I sub n. Now what we're going to do is inside here we're going to flip and multiply because we have division by a fraction. So what we have is that this is equal to log of 20I over I sub n. So this is where all the magic's going to happen. Flip the bottom and multiply. We have I sub n over I. Those I sub n's cancel. They're the same. The i's are the same as well. So what we get is r1 minus r2 equals log, the only thing we have left is 20. So r1 will be log 20 larger than r2, or if we wanted to get a numerical answer for that, what we would have is, we would see that it'd be about 1.3 larger on the Richter scale. So you'll see this so about 1.3 larger on the Richter scale. You'll see this technique used a lot in these kind of problems. In earthquakes, there's a similar application with sound intensity. A lot of times what you'll do is you take the difference in the two decibel levels and do something similar. So this technique applies not only to Richter scale problems, but a lot of these where logarithms are used to measure relative intensity.